Hello, everyone. My name is Ilay Habaz. So I'm a graduate student from Toronto, and I'm very excited to share with you our preliminary feasibility study, which we've been working on for the last few years. The goal of this project was to take the FLS box and convert that into an endoscopy simulator. So there is no conflict of interest, and I wanted to thank the SAGES Research Committee for funding our project in 2015 and 17. So there are already a few endoscopy simulators out there on the market, from virtual reality and non-virtual reality. And although there is good evidence to suggest that endoscopy simulation can improve user performance and skill, the use of the simulators is hampered by their costs. So we thought that we can overcome this challenge by taking the FLS box, which is used everywhere around the world and has been validated for over a decade now, and with a couple of modules, convert that into a whole new simulator. So we called it the best box, and on the left you can see the kit that we have developed. Our goal was, again, to reduce costs as much as possible, so all the components are reusable and there's not a lot of consumables, and we tried our best to preserve components from the FLS box. In the center, we can see the FLS box with a few Velcros that we've added. This took a couple minutes to set up. And then on the right, we can see the best box. And what's neat about this is that this gives the FLS box dual functionality, and it's very easy to switch back and forth. Here's a closer look at our setup. On the left, we can see the front plate that provides an entry point and holds the endoscope in place. And on the right, we see that we do require a flexible endoscope. The goal here was to create a more realistic simulator by providing a regular endoscopic view. Inside, we place the main stage, which mounts all of our tasks, and it is also our final one. We made a short video to run you through the 6 tasks that we've developed. So let's go through them. The first one is the forward peg transfer, where the user has to take 4 pegs and transfer them from one side to the other. The goal here is to increase user scope handling and manipulation. And again, to reduce costs, we're using the FLS pegboard. Moving on to a more challenging version of this task is the retroflexion peg transfer. So it's the same rules, just performed in retroflexion to simulate maneuvering within the gastric fundus or rectum. Moving on to the puncturing task. To increase user needling, we created 6 small targets which the user has to try to needle through. Then we move on to the snaring. So we created 3 different morphologies for our polyps. We're looking right now at the sessile polyp. Next up is our pedunculated polyp. And finally, we'll see the more complex-shaped polyp. The goal here is to snare the black line at the bottom of the polyp. Moving on to the clipping task, we wanted to simulate mucosal closure. So we created 3 different orientations to create some difficulty. And again, to reduce costs, we do not fire the clips. Last task is our cannulation task. So the user has to go through a second channel, which forces him or her to come at 45 degrees with respect to the box here. The goal here is to mimic crossing of a stricture. And there's also a false channel that requires the user to come at a very specific angle and to add some difficulty to this task. So that was our best box. Let's talk about the methods. So 100 participants were tested on the best box by a team of trained administrators. 55 were tested again as a part of an endoscopy course within a period of 4 months. Finally, those individuals were tested on gauges, which is a previously validated global rating tool, while doing an endoscopy on a live animal model by a single trained expert endoscopist. So looking at our results, we do see quite the variance when it comes to training level and skill. But for the purposes of this study, we grouped everyone into two groups, either the expert or trainee. And the definition used here was having done over 200 endoscopy procedures. So the first thing that we wanted to see is time discrimination, and we were able to see, based on time alone, that experts perform significantly faster than trainees. I do want to acknowledge that we placed a 5-minute time limit per task, and we had to stop a fair amount of trainees. We believe that if this limit did not exist, we would have seen even greater differences. Moving on to test-retest reliability, out of those 55 individuals that were tested twice, 24 were used for these analyses. Those were composed of 8 experts. We didn't expect their performance to change all that much, and 16 trainees who explicitly mentioned that they did not practice between the two testing sessions. I do want to acknowledge that for the less complex tasks, we did see a weaker test-retest reliability. We believe that because of the lower mean completion time, this created high variability, which weakened our results. But again, looking at total time, we do see a nice coefficient at 0.783. The last component, we wanted to use gauges to see if our simulator does measure some clinically relevant endoscopy skills. And here's a closer look at gauges. There's 5 sections, each one scored from 1 to 5 to arrive at an overall score of 25. And in terms of our results, we were able to see on time alone a significant correlation with gauges and all of the tasks except the clipping task. So in terms of limitations, as I acknowledged, analysis performed here was based on time alone. We're undergoing further studies to see if we can incorporate error and accuracy into our scoring system. And finally, an endoscopy tower is required. So in terms of conclusions, we think that our initial feasibility study on the first 100 participants suggests that it is feasible to convert the FLS box into an endoscopy simulator. Looking at our preliminary data, we can see that the best box can differentiate between groups, has some evidence for test-retest reliability and correlation with clinically relevant endoscopy skills. And we hope that this shows that our ultra-low-cost simulator will hopefully one day be used for training and potentially assessment purposes. And that really lays the groundwork for further investigation, as I said, with regards to developing a scoring system and potentially correlating it with other variables down the road. So that's it.